Hello and welcome to C++ Weekly. I'm your host, Jason Turner, and as you know, I am available for code reviews, contracting, and on-site training, and you should contact me if you have any interest in these things. I want to be sure to remind you that I am giving a workshop at CVPCon in September, and I am planning to give a workshop at NDC TechTown in September. Now, this episode is about C++ 26's capability of generating new types using the reflection mechanism at compile time. So let's discuss this a little bit, and then we'll see what the options are. This week's episode is sponsored by HRT. If you've attended any C++ conferences this year, there's a good chance you've already heard of HRT, as they have sponsored several conferences. HRT is known for its deep engineering culture and strong focus on performance, and they are looking to hire the sharpest engineers to help them to develop and optimize the technology at the core of their business. They're headquartered in New York, but they have offices in Austin, Chicago, Boulder, London, Dublin, and across Asia. They're looking primarily for C++ and Python developers. I know, since you're a viewer of C++ Weekly, you are a C++ programmer, and you probably already program in Python too. So go ahead and check out the link on the screen for openings that they have. And remember, you don't need a financial background, just strong engineering fundamentals, and they'll teach you the rest of what you need to know. This is a straightforward example that was given to me by Hannah Duzakova, the author of CTRE, and she does a lot of work with compile time and reflection in the standards committee as well. And you have Hannah to thank for all of the standard library constexpr goodness that we are getting in C++ 26. I will say that I modified Hannah's example a little bit, and I will show you what I mean here. And this is, I think, pretty much as small as the example can get, so I'm not going to do the normal thing where I tend to build it up, but I will say that our formatting tools really don't know how to format these things at the moment. There's a couple of new operators in here. This is the, I guess, I'm not exactly sure what this operator is called, in fact. This is the reflection operator. I don't know if there's a better name for it. I am not able to find one at the moment. This topic is still pretty new to me at the time of recording of this episode. The idea is that I want to define some new type. Now, this is all being done with fixed information. Really, I could have accomplished the exact same thing in this example by just declaring struct location with an int and an x and a y in it. But this illustrates how this works. Now, notice this const eval block to start with. This is very new. This is saying everything within this block must be evaluated at compile time. So I'm forward declaring a type. This is my struct location. This only works with aggregate types, just so you know. Then I am defining a vector of meta info objects. These are the members that this is going to have. So this can only have aggregate types, which means it cannot have member functions. There's no way to define a member function here. This is the type that I want to give it. So I am reflecting on this type. I'm saying define something that is of the int type. Now this is actually giving back an object here. If you notice, I'm not going to be putting this in angle brackets and making it like a template parameter or something. And then this is the set of attributes that this thing is going to have. And in this particular case, I'm only defining the attribute for name. So I'm just saying its name is X, name is Y. As far as I can tell, there's no way to declare static members here. That I could be wrong. Might have to look into this some more. Yeah, you can give it a name, you can give it alignment, you can do things like that, but you cannot say that I want to make a static member. So we can just do data members of some particular type. Now again, this is hard-coded, so it's not as meaningful as the example that I will show in a moment. So the result here is this vector of meta info objects, and then I say define aggregate of, notice I'm giving it location here, so it's filling in location. With these members, what I am doing here is declaring a default initialized object of this location type And now I'm saying I want to use location equals the decal type of make location. I'm giving this thing a friendly name, so down here I can come here and do location loc. Now, most of the examples that I have seen look a little bit more like this here and like this. So you aren't needing to have a function or something like that. But the problem is this can only be filled in exactly once. So if I wanted a location and a location 1 and a location 2 or something like that, then I'm going to have to forward declare multiple of these locations. I hope that makes sense. So I kind of flipped things around a little bit. I could not find a better way to do this, but perhaps there is one, and I am making my location type a local to make location. And that way, every time I call make location with a new set of template parameters, I'm going to get a new location type. And I'll show you why that matters in a minute. Just make sure to take a second and pause and look at this and see that the goal is that you're building up a vector of the members that you want, and then you're telling the compiler to fill in a forward declared thing with those members. That's what we're doing. And then I'm going to switch to the more complicated example that shows you a way of doing a little bit more dynamic work here. I'm going to kind of start my way from the bottom and work my way up, and I will show you what I'm aiming for here. I have made a thing that can make a named tuple. So this is, like any tuple that we would want to use, except instead of having to do like get 0, get 1, get 2, I'm able to say dot item 1 equals 42, and I have this integer named item 1 here. So I could see this could potentially work very well for, say, return types from functions that you want to return multiple values or something like that. I don't yet have this so that it is using the actual values passed into this thing. There's probably several different ways we could take this. And in fact, maybe we'll try to modify it live here in this example. But I'm saying create for me a named tuple that has a pair of name types. Pair of name types, just like this. These are class non-type template parameters. This is item 1, is the name that it's going to result in having an item 1 right here. Its type will be int, and its type is an int. Item 2, and its type is double. And this named tuple thing does a forward declaration like we just showed. And then it does a variadic expansion of the pairs of things. Here's the ... that's doing that variadic expansion. And for each element, it is extracting the type name, the type, that was in this name object. So this name variadic pack is a pack of type and value pairs. So it's extracting this type, and it's extracting the name from the thing and doing an expansion. So that is how it fills in the data member spec, and then it does define aggregate of tuple, and it returns the tuple. Now notice that this is a expansion of pairs, and notice that this is a pack of pairs. Pair itself has a name and a type, and the name is just one of these simple static string wrapper thingies that can take a const character literal and make it into something that can be passed as a template parameter. So I'm realizing while looking at this that this is all a bit more, I don't know, heavy-handed or something than I might have wanted. So I am going to try to simplify it real quick. Let's make it so that I can do something like this and just do, I want item 1, item 2, and I want to initialize it with the values 2 and 4.5, something like that. And these are going to be function parameters, like that. And I want this to work. To make this work, named tuple needs to no longer take a variadic pack of pairs. It needs to take a variadic pack of static string objects. and I need a matching pack of values. Cool, that worked. That's actually really handy and shows that perhaps we know what we're doing a little bit here. Now, what we might be able to do is do something like all right, so we've got this generate data, and I could do something along the lines of return generate data dot value right here. That should work. And if I were so inclined, I should also be able to destructure this with a structured binding. I should see that 84 is being returned from main now. 0 is being returned from main because I did not properly initialize these values. There you go. Now 84 is being returned from main. And as you can see, all the compile time trickery went away. Maybe this would be useful in C++ 26 for returning multiple named things from things. I don't know. I'm sure that this is a thing that people are still investigating and playing with to see exactly what you might be able to do. This is where I went with it. I hope you find this episode interesting. Thank you for watching C++ Weekly.